Good afternoon. Good afternoon. My name is Sergio Cruz, PhD student of the PMPCA, and the title of my work is titled Optimization of the Synthesis Conditions of Hydrochar and Pyrohydrochar of Pleco Fish Bone in the Removal of Fluorides. To begin with, what hydrochar are. Hydrochar are materials that are produced by hydrothermal carbonization using water as the subcritical point at temperatures between 180 and 260 degrees centigrade. There are several materials that have been used for the preparation of hydrochars such as orange peels, walnut shells, animal bone meal. On the other hand, pyrohydrochar is generated by pyrolysis of hydrochar, which combines the characteristics of hydrochar with a better, resulting in good adsorption performance. Fluoride is a naturally occurring contaminant in water at concentrations above the maximum permissible limit of 1.5 mg per liter set by the World Health Organization and Mexican official standards. The consumption of water with fluoride concentrations above this value can cause dental fluorosis and skeletal fluorosis. The raw material in this work is the pleco fish known as devilfish, which are native to the Amazon and in Mexico occur mainly in the southeast, such as in Chiapas and Tabasco. Because these fish have a high reproduction rate and adapt to changes in water conditions such as pH, salinity, and oxygen, they displace other species, some of them endemic, causing fishermen other than fishing. In addition, the plecos are not accepted as a food alternative by fishermen and therefore have no economic value, which is why it is necessary to look for alternative uses for this fish. Therefore, the objective of this work is to optimize the synthesis conditions of hydrochar and pyrohydrochar from pleco fish bones for the removal of fluoride. In the experimental methodology, to obtain the bones, the pleco fish was sacrificed and the viscera were removed. Then the rest of the fish was subjected to boiling in 2 liters of deionized water and hydrogen peroxide in a 6:1 ratio for 1 hour. After this point, the bones were washed with deionized water to remove the rest of peroxide they might contain. Are subjected to the hydrothermal process in which they are placed in a stainless steel reactor with a Teflon container with water and subjected to a muffle at different temperatures and synthesis times according to the experimental design proposed with the DSIG expert program. After the synthesis, the hydrochar is transferred to an adapted filter paper bag to be washed with deionized water and a salt approximately 8 hours, then the hydrochar is dried in an oven. Once the hydrochars were dried, they were used in the fluoride adsorption experiments in batch adsorbers, at temperature of 25 degrees centigrade and pH equals 7. The hydrochar with the highest adsorption capacity was used to obtain the pyrohydrochar by subjecting it to pyrolysis at different time in the same way by means of an experimental design. Once the pyrohydrochars were obtained, their fluoride adsorption capacity was evaluated. The statistical analysis was performed by means of a response surface experimental design. This optimization study is fast and efficient and minimizes the number of experiments while providing the most information. This analysis was used to identify those operating parameters of the synthesis process that improve the performance of this adsorbent for the removal of fluorides from water. The experimental design was generated using Design Expert 11 software to study the effect of 2 factors, temperature and time, on the fluoride adsorption capacity. For hydrochar, the temperature was 80 to 240 degrees centigrade and the time from 4 to 8 hours. While for pyrohydrochar the temperature was varied from 350 to 650 degrees centigrade and the time from 1 to 2 hours. Within the results, the adsorption capacity of the materials can be observed. In Figure 1a, the adsorption on the hydrochar. The hydrochar with the highest adsorption capacity was the H1 generated the lowest temperature and synthesis time. It is also observed that as the temperature and synthesis time increases, its adsorption capacity decreases. In Figure 1b, it is observed that pH 5 was the one that removed the highest amount of fluoride obtained at 305 hours, and as the temperature increases its adsorption capacity decreases. This may be due to the fact that at higher temperatures hydroxyapatite dehydroxylation occurs. Therefore, pyrolysis favored the adsorption capacity of fluorides at temperatures of 350 to 650 degrees centigrade. Optimization was carried out using Design Expert software to process and fit the experimental values of the mass of fluoride adsorbed in hydrochar and pyrohydrochar to a second-order regression model, generating equations 2 and 3. Which describe the response surface function relating the linear and quadratic interaction effects of the synthesis variables hydrochar and pyrohydrochar levels A and B, and the theoretical fluoride adsorption capacity. These equations were used to perform preliminary regression fits using Excel solver to determine the optimal synthesis conditions for a predicted maximum fluoride adsorption capacity. The optimum values of the synthesis variables for a maximum adsorption capacity of 5.20 per gram for hydrochar were 180 for 4 hours, and for the maximum adsorption capacity of pyrohydrochar it was 381 for 1 hour. Analysis of variance was then carried out to identify the variables that significantly affect the adsorption capacity of fluoride on hydrochar and pyrohydrochar. The results revealed that the synthesis temperature is at adsorption capacity for both materials, while time only significantly affected hydrochar. The conclusions are: the proposed response surfaced the optimal experimental design proposed for the synthesis of the hydrochars and pyrohydrochars from pleco fish bone allowed us to optimize the synthesis conditions and maximize the fluoride adsorption capacity. Fluoride adsorption was carried out on each of the materials synthesized in batch adsorbers at pH equals 7 and T equals 25 degrees centigrade. H1 and pH 5 materials synthesized at 180 for 4 hours and at 350 for 1.5 hours, respectively. It then the highest fluoride adsorption capacity was favored when hydrochar underwent the pyrolysis process at low temperature, and this adsorption capacity decreased with increasing synthesis temperature. Analysis of variance, ANOVA, determined that the synthesis temperature and time significantly affects on the fluoride adsorption capacities of hydrochars, while for pyrohydrochars only the synthesis temperature affects. Finally, it is concluded that deadfall fish bone hydrochars and pyrohydrochars are an alternative for the removal